Alright, welcome to Completing the Square Graphing Edition. So what you're going to do today is you're going to convert your quadratic functions in standard form to vertex form. And you're going to do this by completing the square method. Now, this is something completely brand new. You probably have never been introduced to that, so kind of keeping that in mind, we will try to have quite a bit of practice with this, like on the next time I see y'all, to work on this. So what is this idea about completing the square? Well, first off, let's think about this. Go back to what we did previously. Look at vertex form. And notice again, this was all based on just the graphing addition. I can do this also solving quadratic equations. And we'll look at that later, possibly. But vertex form, we liked it to have in the form of a plus or minus a, parentheses x plus or minus c, close it squared, plus or minus d. Okay? This right here is known as a perfect square, where you have that x plus minus c squared. In other words, you're saying that there's something times itself. Like you're saying x plus c times x plus c, or x minus c times x minus c. Now, if we factor that out, and the reason why that becomes a perfect square is that if we were to multiply that, like say x plus c squared, then we would end up with x plus 2c x plus c squared. In other words, whatever happens here, this number would get doubled and be put in front of the x, and then you would also square it to get that, and you have the x squared. This is known as a perfect square trinomial, and we can factor it to that. And so what we're going to do is we're going to take, say, a quadratic function that might look something like this, and try to get it to this. Oh, sure, that sounds very, very scary and interesting. Well, let's look at that. Let's look at an example. Okay, and this is one of those kind of follow the steps, and you'll start to see it a little bit better. Okay, so here I have x squared plus 6x minus 2. The first thing I do is this. I need to separate my two x terms away from the constant term. So I'm putting in parentheses x squared plus 6x, close the parentheses, and minus 2. And what I'm about to show you, other teachers might do it slightly different, but I'm kind of also trying to shorten up some steps here too. So I'm kind of doing this all in, I'm shortening this up like 1 or 2 steps based on what I've seen other teachers do. Okay? Now, so the first thing I do is this. Go ahead, next step, just put here x. Notice I have a blank space in that parentheses. Well, you'll fill that in later. Now go to this, and so from this step, from here to here, you're going to write parentheses x blank. Take the sign that you see in front of that x. So in front of the 6, you have a plus. Put it in the sign here. And then divide that number by 2. X plus 3, 6 divided by 2 is 3. Okay, 3 squared is 9. So then I'm going to square that and put that answer squared there. This already right here is our perfect square. This is what we were trying to get to, and we kind of forced it. Now, by adding 9 just out of the blue, which you'll can't do, you have to kind of balance it out. So to balance it out, outside of the parentheses, I need to put the opposite of that plus 9. So the opposite of a plus 9 is minus 9. That balances this out. So you put in a plus here, you're putting a minus there. That keeps it balanced. So that allows you to be able to do this. So you'll always have a positive in here, you'll always have a minus out here. Okay? And then I can combine the negative 2 and negative 9 to get negative 11. And voila! You have it in vertex form. So now you can say that the vertex is excuse me, negative 3, comma, negative 11. And then you could do all that other stuff that we were doing with the vertex form, like finding the axis of symmetry and finding the max or min, in this case the minimum, finding how many roots and what those roots are, and using the graphing calculator to do that. And you would see that if you type this in and this in, you should be able to get the same roots. Okay? So, but we'll try to look at that on the next time I see y'all. Alright, so let's look at another example. Okay, here we go. X squared minus 8x plus 4. And now, again, I'm going to separate the x's from the constant, the number. Okay, then I'm going to put another parentheses under that and put an x. Now, what's the sign in front of the 8? It's a negative, so that goes in the bottom parentheses. What is 8 divided by 2? 4. And then I'm going to square the 4 and put a plus 16 over there. And then that plus 16, if I put a plus 16 in the parentheses, I need to put a minus 16 out of the parentheses. It'll always be plus in the parentheses. It'll always be minus outside. Always. And then I can say 4 minus 16 is negative 12. And voila, I have the vertex form with my vertex being positive 4, negative 12. And it can be that simple. Now, what happens, though, if you have a number in front of the x squared? This is where you get a little bit more complicated. Just a wee bit. Just a little. Small bit. Just a little. Okay. So we're going to start off with the same step. We're going to say put the 3x squared minus the 24x in its own parentheses. And put the plus 53 on the outside. Now, to do completing the square, you cannot have a number in front of the x squared. You cannot, or I'm sorry, you can't have like any number other than 1. So I need to get rid of that 3. So how do I get rid of the 3? Well, I divide the 3 into both the x squared and the x. So if I do that, I'm factoring out the 3. So there's that 3 going out. Obviously, when I factor out the 3, I'm left with just an x squared, and 24 divided by 3 gives me a negative 8. Okay, so notice here how I divided by 3 these two numbers. That 3 went on the outside, this number in front of the x squared, and then 24 divided by 3 gave me the 8. Now I start going through the same steps, but this time I'm going to have a 3 in front of the parentheses. Okay, so I now say, what's half of 8 is 4. 4 squared is 16. And as much as I would love to just add negative 16, I can't, because when this 16, to balance this out, to put it over here, I have to have this 3. It's 3 times whatever this 16 is. So now I need to say 3 times 16 is negative 48. And then I can combine those to get positive 5. And I can see my vertex is positive 4, positive 5. So that vertex is going to end up being positive 4, positive 5. And again, this would tell me, that gives me a vertical stretch, which I would multiply to my magic numbers to do the graph. So again, this all comes right back, but you've got to make sure that this front number multiplies this number and the last number in parentheses to get that number over there. That's balance. All right, last example, and then I'll be done for this one. Yay! Thank you, sir. I know. I'm nice that way. All right, so what I got to do, I got to separate the x's from the number. So 3x squared minus 12x, parentheses, and then negative 4. Then I need to divide out the number in front of the x squared. So divide those two numbers by 3. That leaves me with x squared minus 4x. Still got my little blank space, minus 4. Then again, my next step is put parentheses 3, parentheses x. Because of the minus 4, I'm going to put a minus here inside that parentheses. Notice how there's a minus and then there's that square. 4 divided by 2 is 2. 2 squared is 4. 4 times 3 is 12, but again, positive here, negative there, outside the parentheses. And then negative 4 minus 12 is negative 16. So then my vertex for this one would have been positive 2, negative 16. And there you go. And that's it. That is completing the square by, completing the square, graphing addition. Thank you so much for your time. I do hope to see that y'all will have these notes the next time I see y'all. Thank you so much. Take care.